Right, we now need to put pen to paper and work out what we saw in the experiment by actually drawing ray diagrams to predict what should be the outcomes. So as I said, you're going to draw a converging lens as sort of back-to-back arrow thing, and a diverging lens with these open arrows over there. So that's your cave, converging, at least diverging lens or concave lens, and your convex lens comes like that. Whenever you're going to draw these diagrams, you're going to draw your principal axis and the lens. You're going to label your M, your F, and your 2F as we did in a previous slide, and you're going to do it on both sides of the lens. You're going to label your object O, and you're going to make it a little arrow, and the image ultimately will be labeled I. So, here's my principal axis over here. I've done M, I've measured. There must be exactly the same distance between M and F and 2F and M and F and F and 2F, and you're going to put that all over there. You're going to then put an object as an arrow. In this particular case, my object was beyond 2F. Boom, I put on the beyond 2F. Listen very carefully to what you do then. You will be asked to draw the object at between F and the lens, at F, between F and 2F, at 2F. So you will draw all of those, but just follow this one. You're going to draw one ray from the top of the object, parallel to the principal axis, until you reach the lens. You then at the lens are going to refract it through F on the other side, bend and go through F. You're now going to put arrows on, chunk, chunk, there they are. Draw a second ray from the top of the object and through M until it intersects the first ray. So this is a dead straight line. It goes from the top of the object until it intersects the other ray by going through M. And then you have drawn your ray diagram. Pop an arrow onto that. And then your image, your object started at the principal axis and ended where the two rays met. Your image starts at the principal axis and ends where the two rays intersect over there. You label your image I. Notice your image is upside down. Notice your image is smaller than your object. Real rays, you never had to dot anything backwards. The actual rays met and you got a real image over there. And the image has been formed between F and 2F on the other side of the lens. So, the image is formed where the rays cross one another on the other side of the lens. We need to know its location between F and 2F. Properties of the image, you will either say it's inverted or upright. In this case, it was inverted. Smaller, larger, or the same size. In this case, it was smaller. Real or virtual. In this case, it was real. It will be virtual if I use dotted lines, and you'll see when we need to do that from time to time going forwards. So here's our diagram. The location between F and 2F on the other side of the lens. Upside down, smaller, real because the real rays cross. You're now going to draw diagrams for, you've just done the object beyond 2F, but you need to draw this into your own notes. And you're going to hand this all in. Object between focal point and lens. Object between at F, and between F and 2F. And those 5 diagrams with the description of location and properties needs to be submitted.